welcome back. Monty here, and here we are looking for SPV Math Pre-Calculus, and this is our final get-together before spring break. So our expectations for the week: we got to get logged in, we got to do a couple of assignments, and then we get to enjoy spring break. So let's get started. First of all, just a reminder, we do have a pre-calculus team for SPV. And any of these videos can be found in the stream channel located at the top. And we should have our introductory one, plus the one from last week, plus the one we're making right now. So hopefully that's helpful. Alright, let's go find the internet. Let's go find Spokane Public Schools. Let's find our Clever. Let's find Blackboard. And once we get into Blackboard, we'll click on coursework. Last week we focused on the identities. Okay, on the trig identities. All right, and we did some practice, and some of the problems were long. Okay, this week we're going to try proving trigonometric identities. All right, so let's see if we can get through this week. So we'll click on Math Excel for School. We're going to go to Pre-Calculus, and a couple weeks ago, and then last week. And this week, let's try Algebraic Manipulation to simplify and prove. Sounds tough. Okay. Alright, let's shrink this down a little. And let's see if we can simplify this to an identity. Now, on a lot of these, they will help you. Okay? Alright. Grab our sketch pad here. And right off the bat, 1 minus cosine squared of x. Notice, this is from the Pythagorean theorem. A squared plus b squared equals c squared. Well, when we use it for trig in the unit circle, we have sine squared x plus cosine squared x is equal to 1. We subtract it across. This is what we're interested in, and it's on our trig identity sheet under there it is, the Pythagorean theorem. Cosine squared plus sine squared minus equals 1. Subtract from both sides. All right? Okay. So now back on our problem here. So we're going to substitute this for this, giving us f of x is equal to sine squared x over cosine x. Well, sine squared x over cosine squared x, isn't that the same as saying sine of x over cosine x times the sine of x? And that's a tangent of x sine x. It's asking if sine of x is an identity. I'm not seeing it. I'm going to say no. Yep, good. Alright, so my agreement was I'll try the first and the last one. So let's go to the last one. If f of x is equal to g of x is an identity, and f of x divided by g of x equals k, which of the following must be false? Well, we can't divide by 0, so no. It doesn't have to be 1, no. F of x equals 0, no. You know what I do like? Look at B. Okay, f of x equals g of x. Let's just pick a number, okay? Let's just say 1 equals 1. Well, if we subtract 1 from both sides, we get 1 minus 1 equal 0. That last one said sine of x, right? F of x was equal to the sine of x. Subtract that, it has to equal 0. If we subtract from both sides, I really like B. I really like B. Examine each choice systematically. Assume the choice is true. Assume the choice is true and determine whether or not K is false. Oh, which one is false? Which one is false? Okay, sorry. Which one is false? It can't be C. It could be 1. 0 is equal to 0. I'm going to say okay. I'm going to try C. It can't be 0. It can't be 0. F of x can't be 0. Wait a minute. Okay, we know this is true. Could it be 0? 0 divided by 0. Okay, I had it right the first time. It could be 0 because 0 is equal to 0. If it's equal to each other, then you multiply them. Must be false. The only one that has to be false, because if that was true, then this would, okay, C. C. Yep. I read must be false. Those always get me. Yep. Okay, let's go try next guy. Basic identities to manipulate and prove. Basic identities to manipulate and prove. Okay, prove the algebraic identity by starting with the expression on the left and supplying a sequence of equivalent expressions that ends with the expression on the right. Wow, this sounds long. Okay. X to the third minus x squared over x minus x minus 3x plus 3 equals 9 minus x. All right, step 1. X squared. So x squared, x minus 1 over x. X to the first equals x to the third equals x squared over x. Okay. Minus x minus 3, x plus 3 equals 9 minus x. Okay. That and that. So now, step 3. X minus 1 minus x minus 3, x plus 3 equals 9 minus x. I want to do this. I want to test this. This times this, 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 this times this. Let's see what happens. X squared minus x minus x squared minus 3x plus 3x minus 9 equals 9 minus x. Now, don't want to make a mistake. That times that. That cancels that. So then this is going to be minus 9. Okay, so that was step 4. Step 5. X squared minus x squared plus 9 equals 9 minus x. X squared cancels out. Negative x squared negative x plus 9 equals 9 minus x. Choose the correct transformation and transform the expression for each step. Negative 1 x minus 9 equals 9 minus x. 9 minus x. We already got it. Yes, got it. Got it. Those are the same. All right. So now, well, to me, I cancel common factors there in green. Okay? Okay, I cancel common factors getting x, parenthesis, x minus 1, close. Okay. Multiply and when we multiplied all this, without simplifying, minus x squared plus 9. Combined like terms, sorry. Okay, all right. Now let's try the last one. Okay, let's take a moment here. Sheesh. Establish the identity. Gulp. Cotangent secant minus 1 secant plus 1 tan cubed. Cotangent, no idea. So cosine over sine. Secant is the cosine, right? 1 over cosine minus 1. Over cosine. Equals 1 over cosine plus 1 all over tan cubed. So okay, I'm liking this tan here. I can see multiplying both sides. Multiply top and bottom by tan. Multiplying top and bottom by secant. multiplying top and bottom by the positive. No. Establish the identity. We're starting here to get to here. So they're looking at the first one, they're looking at the first one, they're looking at the first one. Okay. So we're going to multiply top and bottom by tan. We're going to take the first one and we're going to multiply by the minus 1. I don't like that at all. Because that doesn't, no, because we're not, no, because right here, you're going to have minus 2 secant, so B can't be B. All right, now if you multiply by the complex conjugate, the middle term goes away. All right, okay, so if we multiply by tangent, how does that get to that? Tangent, it's going to be C, okay, all right. Now, all right, so the first thing is the complex conjugate. Complex conjugate, which is secant plus 1, so the middle term goes away. So the cotangent, secant minus 1, secant plus 1, secant plus 1. All right, so that times that, we're going to get cotangent secant plus 1 over secant squared minus 1 minus secant plus secant minus 1. Now, 1 over secant squared, is that an identity? Secant squared right there, boom. Secant squared tangent. Secant squared minus 1 is tangent squared. Tangent squared. Tangent squared. This gives us tangent squared theta. Tangent squared theta. Alright, so now cotangent secant plus 1, and this is tangent squared theta. Now secant. Secant is 1 over cosine plus 1. Cotangent is cosine over sine. So that over that. Oh. Okay. Now, divide. Take this and bring him downstairs. But if you take it downstairs, remember you flip it, divide by a fraction, multiply by the reciprocal. So if we bring him downstairs, secant plus 1, brought it downstairs, and we have tangent squared theta times sine cosine, right? Because if we take this upstairs, you have to flip it. Secant plus 1 over tangent cubed theta. Okay, bring it downstairs, you bring it downstairs, bring it downstairs. I'm going to say C. Yeah. All right. So these are long problems, and just remember, this is the last thing we have to do, and then we're going to have a good spring break. All right, so pre-calculus, folks. Have a great week. Have a great spring break. If you need anything, let me know. Monty signing out.